guys aren't gonna let any of your teammates in, or you guys just want to?
They're all presenting now.
They're self-presenting now.
8 and 8, 10.
I don't understand why Chris was saying it's usually in 4 places.
There needs to be 2 of you left. There needs to be 2 of you to make it to Hamilton.
Whenever y'all are ready.
Good morning. Here on the Virginia Tech team. We'll be presenting today on the job we've been working on, the CSX Bridge 2A. I'm Brett Dietrich.
Melissa Peebles.
Brad Smith.
Alex Schreck.
Matt Kaiser and Cody Johnson.
We're going over the agenda we're going to be going through today. We're going to talk a little bit about our project overview and how we approach the problem itself. We're going to talk about our site layout and work schedule, the scope of work we have included in our costs that is given to y'all, our risk, our indirect costs, and we'll wrap it up with the conclusion. Now, Alex, talk a little bit about our project overview.
As Brett mentioned, we're going to be doing the CSX bridge removal and replacement, which is located in the middle of the screen here. It's located in Baltimore, Maryland, and as you can see, the area is pretty congested. We're going to be working over active Amtrak lines and in the general vicinity of a major highway. After deliberation, we were considering a few laid-out areas, but we got an addendum that had to change our mind, and so we ended up going with the rolling concrete yard as our laid-down area. We decided that this had an efficient amount of space and would provide all the access that we needed throughout construction. We're going to tackle construction in 4 major sections, which I'll talk about next. The issues we foresee are active railways, tight closure times, space restrictions, and maintaining electromagnetic lines throughout construction. Our lump sum price came out to $7.4 million, and then our total price with direct and indirect was $15.6. The general approach and the 4 sections I was talking about are listed here. The first thing we're going to do is fabricate and erect the new bridge, and that's going to be a 6-month window before the actual 40-hour span. Finally, once that 40-hour span hits and we're ready to go, we're going to remove the existing bridge, set it in our laid-down area, and deconstruct that at a later time. After that 40-hour window, or during that 40-hour window, we're also going to replace with the new bridge, which we've broken down into 2 sections. We're going to replace the far side first, and then the closest side, or the nearest side to our laid-down area second. And once we wrap that up and our 40-hour window closes, we're going to deconstruct the old bridge in a 2-month span afterwards. I'll take it to Brad, who will discuss a little bit more about that site layout.
Thanks, Melissa. So we'll be using the existing concrete plant for the placement of our job trailer as well as our laydown area. This area is not only big enough, but it's just easy to get to. In order to get the crane in a safe location on the site, we're going to have to do some clearing and grubbing, just remove some trees or some bush hogging. Since we're going to be removing some of this vegetation, we're going to have some erosion control in place, and once we're done with everything, we'll be putting it all back, or re-sealing everything. Here's a diagram of our overall site plan. To get to the site, we're going to be using the access roads through the existing concrete plant. Down here in the bottom right, you can see where our crane is. It's sitting on top of that vegetation that's going to have to be cleared out, so we'll have to make sure we get to that first. Since we can't store things very close to the railroad tracks, we're going to be using the laydown area in orange. It's not only a good spot for the crane, so it is a good spot for the crane, so you can just pick up, move right over to the construction site, place everything right there. The laydown area was designed to be big enough so we can put the old bridge there, and while it's there, we'll be able to take it down or deconstruct it, and we can also put in the new bridge and fabricate it right there. We designed this site so it's not only maximizing safety, but it increases productivity, and we're staying out of the way of the other trains that are going around us. Now take it to Allie for scheduling.
Bridge 2A is a very schedule-driven project. We have 2 major milestones we have to meet, the 40-hour period, as well as our substantial completion on October 31st, 2015. Using our notice to proceed of yesterday, October 30th, we're going to start on Monday, November 3rd, and finish on September 9th ahead of schedule of over a month. This schedule behind me represents our durations on the left in weeks, with our activity breakdown, and our critical path is in red. We have 2 major driving factors. The delivery and assembly of our fabricated steel is essential to our critical path. Without those, we cannot start our 40 hours and construct the new bridge. Resources that drive our schedule include our delivery lowboy, which will deliver our 21,000 lever crane. Furthermore, the RT cranes, one is used for the erection of this crane, as well as the other for non-substantial lifts. Finally, the loader will assist with our 21,000 libra crane, so these all drive our 40-hour window. Finally, critical path is indicated in red here. We allotted a certain designated 10-week period for receiving and then fabrication of the steel, and we also included lead time in this duration. However, we understand we can start delivery early, which is why our critical path can actually start early and we can complete even earlier than scheduled. At this point, I will turn it over to Matt for demolition.
Okay, deconstruction of the bridge will happen in two parts, removal and disposal of the bridge. The first part, removal, occurs during the 40-hour change-out span. The bridge is approximately 150,000 pounds, so we will need to use the big crane on site. Removal of the bridge will happen with our team disassembling the bridge from the abutment, and then the crane will pick it up in one piece and swing it over to the lay-down area, where then it will let it off and we can begin destructing it later on. So this goes to phase 2 disposal, which will happen over the 2-month span. We will have a team break down the bridge into 20-foot sections, load it onto the low buoy for removal by the subcontractor. This is the bridge being disassembled. The new bridge is already up, as you can see, because this is not during the 40-hour change-out span. This is months in advance. And now I will give it to Cody for the erection of the new bridge.
Thanks. The new bridge will consist of 197,752 pounds of steel. We've subcontracted that out to 2 companies. One will provide the bearing plates and the other will provide all the steel, such as the web plates, the girders, and the diaphragms. The company that's supplying the steel is called High Steel, and their price was $2,115,000. And all the deliveries will be made by truck. And as Brad said earlier, they will access the laydown area through the concrete yard. And this way there will be no railroad interference during this part of the construction process. The new bridge will be erected in 2 equal girders of about 90 to 95 feet. And this will be done in the laydown area prior to the 40-hour window. And this will be about a 6-month process. It will be completed by 1 crew, including 1 foreman, 4 iron workers, 2 laborers, and 2 extra high operators. And now I will turn it over to Brett for the 40-hour window.
As Ali mentioned earlier, this is a very schedule-driven project. So it's critical during this 40-hour window that we get not only the removal of the existing bridge, but also our change-out span into place. We felt that it was the best way we could approach this, breaking our new bridge into a 2-span process with coinciding activities at all times. Some major equipment that we've used is a gantry MyJack, the Libra 21,000 crane, a loader, and the RT cranes as well. So as you can see here, once the existing bridge is removed and laid down in our yard, we'll begin by placing our gantry MyJack at the north end up here of the bridge. The reason we chose the north end first is that way once we lay down the first span, we can have a crew come in and start laying down rail as we're getting ready to set the second girder. This was detrimental to our process as it allowed our schedule to be moved up a little bit and sped up the overall timing of our 40-hour window. Once the gantry is in place, we will set the first girder. Because these are swung over so far of a distance, we had to make all these lifts are critical picks. And so at all times during critical pick, the entire laydown area will be clear of all personnel besides crane spotters, any assisting equipment such as the loader or RT crane that are helping the crane actually get its connections for the girder. Once the first girder is put into place, again, we will start our rail laydown and our ties. Once the second girder is ready to be hoisted up, all personnel on the actual bridge will be removed as well, to prevent any kind of safety hazards that may happen due to this. Again, once the second girder is put in place, our crews will get back on, start laying down the remaining rail, the field splice in the middle, and any other type of miscellaneous work that needs to be done for us to get out of there in our 40-hour period. Train will not be running there, we just had it there so you can see the tracks. Once our girders are both put in place, we will dismantle the gantry system, and then demob of the crane will begin. Again, this will be coincided with the actual rail tie. The crane is not detrimental to that process, and so it'll be removed to speed up our time. With that, it'll go back to Allie for a little bit of our risk on the job.
CSX Bridge 2A is a high-risk project. The list behind me represents some of the recognized risks we just chose to highlight for you all. Beginning with delivery delays, as I discussed in the CPN, we do have delivery and assembly as essential parts of our schedule, and therefore we've allotted in our durations lead time, as well as we've planned to have those kind of scheduled and prepared ahead of time. Furthermore, railroad damage is an essential part. We have live Amtrak train tracks below our construction, so we want to make sure that those are not damaged by no construction occurring there. Furthermore, use of the CSX tracks next to the bridge. Our crane will straddle that using the crane mat, as well as all our cranes have rubber tires, so no damage can occur. The electrification lines, coordination with Amtrak will be done to protect these lines. But also we included a little contingency should a temporary structure need to be constructed. The wetland protection. This area is not to be touched. We've already put silt fence around it. We want to make sure nothing happens to it, no picks are done over it, and no construction is done in the direct vicinity of this area because it is part of the watershed. And finally, damage to existing structures. We're using the existing abutments in some areas, so we want to make sure that those are structurally significant and that they can hold our new bridge, and therefore a structural analysis is performed. At this point, I'm going to turn it over to Melissa for indirect costs.
So as Alan said, this is a high-risk job, and we wanted to make sure we covered that in our contingency. Our contingency is roughly $2 million. I know that sounds kind of high since our lump sum is only 7.4, but again, there are lots of things that can go wrong, and if it happens in that 40-hour span, we're in trouble. And so we're including here in the contingency things like, okay, we get there, we pull the bridge, and the abutments crumble underneath us. You know, what happens if we cannot set a new bridge there? We're also considering things such as we get out there, we try to make the big, and our crews and our operators, they don't feel comfortable with that. We want to make sure that we attack this the right way. With that, we do have a backup plan if something were to happen and our crew members say that, you know, this isn't a good idea. So we do plan for that. Our overhead is roughly $500,000. We're going to have a PM, a superintendent, and 3 engineers throughout the life of the construction, and that is, you know, the 6 months before for the 40-hour window and the 2 months after. Our profit is roughly 7%, which was what brought us to our $15.6 million total cost. And with that, I'll give it to Brett to wrap it up.
We feel that our method, as well as our risk analysis, our schedule analysis, give us the best opportunity to finish this job not only within schedule but ahead of time, as well as under cost, and without risking any kind of safety to existing CSX line, Amtrak line, forestry, or any the road and concrete yard, as well as any of our personnel. And with that, we will open the floor for questions.
I had a question for you on demo. With the weight you calculated for the bridge to remove, is there any prep work that goes into, are you dismantling anything on the bridge before you're picking it, or are you just disconnecting it from the abutments and picking the entire structure?
Correct. We're just dismantling it from the abutments, and then we're taking it in one piece.
Okay, so that includes all the floor beams and track.
Tell me about this gantry, where's that?
We couldn't find a picture of one, but I used to live in Maryland. When they were doing the Dulles Phase 1, they were using a gantry for the airway segmentals, and obviously ours won't be nearly that size. But the way we perceive it to work, and our engineer is currently getting back to us on the specifics and details of how it's actually going to work. But the way we saw it is it's going to be posted on the north end on the existing ground, up against the edge of it, so it won't be near the Amtrak lines at all. And it will, as it's as the segmental is set there, it'll hold on to the segmental as it's held on to the end. And it'll have arms that extend out that support it throughout the entire span. So and it can move along with the legs stay in place so that it can move along the edge of the span, or the bottom of the span.
So would that get in the way of the Amtrak lines at all?
No, the way the segmental was done for the Dulles job was it was done where there was an existing highways underneath it, and it caused no destruction or no closures at all. It didn't even come a foot below.
The legs set in place.
The legs set in place
top
while
of
the
the
gantry
structure
moves
moves.
along more the top and sides, and it doesn't have anything underneath besides the legs.
What are you supporting the end with,
The end of the gantry or the end of the span?
end of the span?
The span, once it's set into the gantry, it'll be fastened immediately.
So it's cantilevered out.
It's cantilevered out, and that's why we have the gantry in to support the
Draw me a
cantilevered
picture.
side. Draw you a picture?
Draw me a picture.
Alright.
While he's drawing a picture, have you guys got a couple things that identified as your risk, right? So you got delivery delays, the rail damage, electrification, wetlands, damage to existing structures. But you don't have, where's your risk for